We're going to look at how to simplify ratios. So if we've been given a bag of M&Ms with only 4 red and 6 blue in there, then we can say that our bag of M&Ms has been split into a red and blue sweets in the ratio of 4 to 6. Right, there's 10 sweets in the bag, 4 are red, 6 are blue, so we write that as the ratio of 4 to 6. So what ratios actually do is they allow for comparison. We can then compare the contents of that M&M's bag. Right. Now when we're looking to simplify a ratio, what we're trying to do is actually scale down and scaling down equally. Yeah? So if our ratio is 4 to 6, then what we're doing is we're looking for a common factor. We need to find a number that we can divide both 4 and 6 by, so we can scale both the numbers down equally. So in this case, because they're both even, the easiest factor that we can use is 2. So we can divide both 4 and 6 by 2, and we end up with a simplified version of 4 and 6, which is 2 to 3. Right, so the ratio of 4 to 6 can be simplified down to 2 to 3. Again, it allows for comparison. So what that's saying is, for every 2 red M&Ms, there will be 3 blue M&Ms. So if there's 4 red M&Ms, there's going to be 6 blue M&Ms. If there's 6 red, there's going to be 9 blue. Okay, so we can scale up using that. Okay, so we can also write the contents, the ratio, in the form of a fraction. Right, so in the packet there are 10 sweets, because 4 plus 6 is 10. So out of that 10, 4 of those are red. So we can write red as 4 tenths, 4 over 10. For every out of every 10 sweets in the M&M's bag, 4 are red, so 4 tenths. Again, that can be simplified. We'll do that in a second. Blue can be written as 6 over 10, because out of the 10 M&M sweets, 6 are blue. Yeah, we can simplify both. We're looking for the common factor, which is 2. We divide the numerator and denominator by 2, and we end up with 2/5 and 3/5. Yeah. Again, the key bit there is to understand that there's 10 sweets in total, and out of that 10, 4 are red and 6 are blue. From there we can write those fractions. The last bit, the simplifying ratios, is also equivalent ratios. Equivalent ratios is linked to simplifying ratios. But where we simplify, we scale down. With equivalent ratios, we can scale up or down. For this case, we're just going to scale up. To scale up, we're actually looking for multiples. Right, we're scaling up equally, so we're looking for multiples. And what we're going to do is we're just going to multiply both parts of the ratio by a integer, positive integer, to scale those ratio parts up. So for example, 4 to 6 can be scaled up if we multiply both parts by 3. Therefore 12 to 18 would be an equivalent ratio. So 4 to 6 has an equivalent ratio, which is 12 to 18. Another example, there's as many examples as we can write for this. So 4 to 6, we can multiply both parts by 10, and we end up with 40 to 60. 40 to 60 is equivalent to 4 to 6. So if we simplify 40 to 60, we get 4 to 6. So those are equivalent ratios. Again, they allow for comparison.